Is there anyone here who's currently using PGP, GPG? Okay. I'm going to guess that anyone else who's sitting around is somewhat interested in it at least. For the most part, the two different applications are PGP and GPG. And if you're command line oriented, I would probably recommend GPG. If you're more GUI oriented and want something that you can look at and click on, then probably I'd recommend PGP. And being that I've had 30 seconds to prepare for this, probably just want to start off, and since we've got a small group of people, is there any particular questions that anyone has about PGP, GPG? Okay, we'll just do this very informal. If anyone has any questions, just put up your hand or start shouting. Basically, what PGP and GPG do is they both format messages and create and interpret messages using an OpenPGP format, and OpenPGP is defined in RFC 2440. And what it does is it allows for encryption and authentication using public key cryptography. And what public key cryptography does, which is very cool, is if you want to exchange secret messages with someone, instead of having to coordinate beforehand what your secret key is, which is what you would typically do using a symmetric cipher, is you generate a key pair. And the key pair consists of a private key component that you keep private and a public key component that is available for distribution and you give to everyone. And symmetric cryptography, which is what most people think of when you think of cryptography and encryption, means you're going to take a file and encrypt it using a password or passphrase. And if somebody else wants to decrypt that file, then they're going to need the passphrase to decrypt it. And of course the hard part is how do you securely communicate that passphrase to someone else if all you have is an insecure channel to communicate with. And the internet is a good example of an insecure channel, and that anyone can listen in on it and you're not going to know about it. So PGP solves the problem by using public keys, and what the public key does for encryption is if I have my private key is kept a secret and I publish my public key, then anyone can take my public key and encrypt a message to me that only I can decrypt with my private key. And it's kind of like, if you think about it, it's kind of like a hopper, what they call a hopper top safe. You've probably seen in a convenience store where they have a safe with a kind of a hole in the top where you can drop the money in, but you can't get the money out unless you know the combination. And that's kind of the way that PGP works for encryption, in that with a public key, anyone can put a message into that safe, but only if you have the private key can you get the message out of the safe. And that's basically what PGP does for encryption, and kind of a oversimplified version of what public key encryption does. Public key authentication, what that does is if I send someone a message, or let's say I post a message to a mailing list and I sign that message, it would be pretty difficult for me to later say that I didn't post the message to the list. Now, most of us know that email headers are easy to spoof. They're trivially easy to spoof, so that anyone could send something to a mailing list and make it look like I sent it. But if they want to send a message to the list that's signed with my signature, it would be mathematically expensive for them to do, bordering on impossible, but at the very least, let's say it's infeasible. That using big enough keys, it's, depending on which book you read, it's going to take somewhere in the ballpark of all the computers in the world, billions and billions of years to figure it out without the private key. So what that does is it provides authentication. Now, one of the things where it comes in real handy is if you're installing code that you download from the internet. How many people check like an MD5 checksum when you download something? Okay. Now, an MD5 checksum is good for basically all you can check with an MD5 checksum when you download a piece of software or download the code for it is that what you've downloaded agrees with what's on that website that you downloaded it from. The problem, though, is if the website's hacked, it's really easy for whoever hacked the website. Let's say their goal is to install malicious software, so you download it and install it. And if it's all you have to check is an MD5 checksum, and you're getting that from the same place that you get the software from, then chances are that that would be compromised too. So you're checking a checksum that's compromised just the same as the software. So you check it, you hash your program, you check the hash against what it says on the website, it looks good, but it's hacked and you don't know about it. PGP would solve that problem by making a cryptographic signature of the software. You can then download the person's public key and check that the software you downloaded and the signature that you have on that piece of software, that piece of code, is a valid signature by their key. And that way, unless their key is compromised, it's pretty much impossible for someone else to slip in malicious software and have it pass the signature test. So what it does is it gives a cryptographic level of authentication to double checking that what you downloaded is what you think it is, to the authenticity of the information that you're checking. Do we have any questions so far? Any question at all? PGP. I can't hear you. I still can't hear you. Just shout. Has what? Okay, it's about the compatibility between RSA, El-Gamal, and the different asymmetric algorithms. Okay, there's the basic overview of the different algorithms used by PGP and GPG is divided into the symmetric and the asymmetric algorithms. So we'll talk about the asymmetric algorithms, of which primarily what we're concerned with right now, what's currently available and wide use, is going to be RSA, which can be used for encryption and signing. There's El-Gamal, which they used to use for signatures, but they don't use anymore. And there's DSA, which is actually DSS, which is only used for signatures. And used to be compatibility issues in older versions of in the PGP brand of PGP, because RSA was a patented algorithm that wasn't included in GPG, and it was a big used to be a big problem because everyone who was using PGP brand of encryption had RSA keys, and everyone who was using GPG had El-Gamal DSA keys. And anymore, though, since the RSA patent expired in 2001, you can now use RSA. It's fully compatible with GPG, and you can generate old style keys using GPG. And I think the default setting, even now on the PGP brand product, is to set up a DSA primary key with an El-Gamal encryption subkey. Does that answer the question? Okay. Okay. Yeah, it's been a few years now that since the RSA patent has expired, that it's in the public domain. Anyone can use it. I don't use the PGP brand product, so I'm more of a GNU PG guy. So I'm not sure what version of PGP it was where they started using the other algorithms, and I'm also not sure off the top of my head what version it was of GPG where they started to use the RSA. El-Gamal is what most people are using for encryption. Myself, I'm using an all RSA key. There is an El-Gamal subkey, but it's superseded. There is also a DSA subkey on it, which is also superseded. mostly, for the most part, if you're just going to generate a key and not fight with it too much, and you go with the defaults, it's going to generate a DSA primary key with an Elgamal encryption subkey. And that's what I'm going to guess somewhere in the ballpark of 90-95% of what's out there, at least among GPG users, is going to be. That's what you're going to run into, is a 1024 DSA primary key, typically about a 1024 or 2048 Elgamal encryption subkey, which, if anyone's, it should be compatible with anything PGP brand version, at least 5 or 6 or newer. Version 2 is going to be version 2 of PGP brand is I think that's RSA only, but I think everything since then should be compatible with the other algorithms. Okay, the question was, if you have a PGP key that's been in use for many years, and there's a user ID section, it's a UID field in the key, and after a certain amount of time you go through email addresses that are now expired, how do you get those out of the key, right? And once something is attached to a PGP key, it's pretty much going to be there forever throughout the key servers. Things tend to be added to a key. Things tend to not be taken away from the key. What you can do, though, is issue a revocation. You can revoke a user ID. And have you done that with any of your older IDs? Okay, but the key that you're using now, you still have multiple user IDs on it, and only one of them is current. What you can do is you can issue a revocation certificate against the old user IDs, and you can just say that they've been superseded, they're no longer in use, something to that effect. And then what happens is the revocation certificates, those make the rounds through the key servers. And then what you can do also is you can edit your key locally so that if you get rid of the user IDs locally. Now, if someone imports your key from the key server, they're going to get everything that was ever attached to that key, including all your expired user IDs, revocation certificates if you issued any, so those user IDs, they'll recognize that they're not current anymore. And what you can do, though, if you give someone your key, is you can edit out all the expired UIDs. So you can give someone a bit more of a compact key that's only going to have current information on it. Have more questions? More stuff that people, yeah. Okay, you don't, the question was, do you register your key with the server? You don't register the key to a server. What you do is you can upload, if you want, you can upload the key to a key server. And if you don't want, someone else might do it anyway. If you're just using the key to communicate with someone else and you don't necessarily want the key to be publicly distributed, you can make it known amongst whoever you are communicating with that the key's not intended for public distribution. For most of us, though, what we'd want to do is take the key and upload it to a key server. And what a key server does, so if somebody wants to find me, they know my email address is adam@smasher.org, but you don't know what my key is, what you would do is you go to a key server, type in my email address, and it'll say, here's my key. And that makes it easy to find the keys. Now, if you want to find out if it's really my key, then what you do is you look at the signatures on the key, and you try and find a path from your key to my key. And then you can determine for yourself, if you consider my key to be trusted, that my key really is my key. That answer the question? Anyone else? PGP, GPG, crypto questions? Anybody? Help me in lieu of preparation. Okay. is the guy who wants to talking about the radio stuff here? Well, hand it over to him early if there's no more if we don't have any other questions. Anybody? 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 Who's doing the next talk? Hmm? Okay, you're stuck with me then. Can anyone think of a stupid question? I don't, I promise not to laugh. Okay. How many people in here are actually using PGP, GPG? And how many people are intending to use it? Um, as far for a GUI interface for GPG, I'm not sure what they have. There's a few things that you can use. There's KGPG under KDE Desktop. There's Seahorse, which is a similar thing under GNOME. And there's a few other things that you can use primarily for managing keys. Um, if you want it to decrypt, there is in GPG there is a batch option and there's a multi-file option, I think, and don't I haven't used them myself, but you might want to read the man page on those two sections. Okay. Then you might want to do you might have to write your own script. Now you're talking about asymmetrically encrypted files. Hmm? Oh, okay. With the -C flag, so you're talking about a symmetrically encrypted. Um, yeah, if you're doing that, you'd probably want to do is write a script and just use the passphrase file descriptor option, passphrase FD. I don't think there's a more efficient way to do that, other than the possibility of I think it's under the GPG 1.9 branch, which is heavy development. There's a GPG agent which can store your passphrase, kind of like an SSH agent. And once you have your passphrase into there, then then your GPG can read your passphrase from there. I'm not sure how that works with multiple passphrases if you want to use like a symmetric and an asymmetric at the same time. I think the development is primarily focused on the asymmetric just to unlock your secret key. Well, asymmetric either for signing or for decryption. But what it would do is you type in your secret key passphrase, and then that'll make your secret key accessible to GPG, so you don't have to type it in every time. But that's I think that's only available in the 1.9 branch, which is, you know, use at your own risk. Is RSA stronger than DSS? It depends on who you ask. Um, okay, excellent question. Why is DSS the default? DSS is the default because RSA wasn't available publicly at the time when it came out. Is this thing breaking up? How about now? Okay, much hotter mic. Okay, DSA is the default primarily because RSA wasn't available at the time. When RSA wasn't publicly available, then the other algorithms pretty much came into place because RSA wasn't available. And as a convention, they've pretty much stayed in place throughout a lot of the implementations. Mathematically, it's generally considered that bit for bit, if like let's say you're comparing 1024-bit keys, that DSA is going to be slightly stronger than RSA, and El Gamal is going to be slightly stronger than RSA. There are some, actually it's very important to, when you're dealing with RSA and El Gamal type of keys, that you verify the source code or your binary as being legitimate, because there's a very simple attack against DSA that would allow someone to recover your secret key from anything that you've signed. And it's not one of these mathematically theoretical attacks. It's an attack that takes about 30 seconds real-world implementation. Obviously, if you're dealing with a compromised binary, then it doesn't matter what the algorithm is. Someone could steal your password from it and email it to themselves or whatever. But that's a particular attack that's of concern to DSA signatures, and could also be a weakness in El Gamal encryption. So, very important to check your binaries and check your source code if you roll your own binaries on any type of cryptographic application to make sure that you're getting what you think you're getting. You want to be wary of accepting gifts from strangers. If somebody says, here's a new GPG binary, I just added some stuff and tested it out. Go give it a test drive for me, see how it works. Not a good idea. Just get the patch files from them and roll it yourself after you look over the patches. As far as any other security aspects between the algorithms, if you're using reasonably large keys, they're all going to be comparably impossible in practical terms to crack any messages in them, assuming that they're used properly. And as far as anybody knows, using today's technology and today's algorithms. Yeah, as far as the default goes, depending on, and I should say depending on what your paranoia is going to determine what algorithms you use. My paranoia tells me to use RSA keys. Someone else's tinfoil hat might be whispering into their ear, don't use anything but RSA. So there's nothing in the published literature that proves or disproves any algorithm to be better or worse than any other by any significant degree. But just do your own research, and if you have a hunch, go with your hunch. Or if you work for the NSA, then that might influence your hunch, but you probably can't tell me about it. The what? Okay. Regarding the symmetric ciphers, the default preferences in GPG are the AES variants, AES 256, 192, and 128. Then I think cast is the next default, and then triple des, which is, according to the PGP standard, is going to be an always available default. Personally, I'm a bit wary of the AESs, only because their reduced rounds versions of them are 75% broken. But again, do your own research. There's nothing. Right now, the only viable attacks are going to be, the only attacks against them are more theoretical than practical. But just, again, do your own research and go with your hunch as far as setting up preferences and what you want to use for yourself. But triple des, if it's used properly, is, for all practical purposes, going to be, right up there with anything else that's current. And it's got 30 years now of cryptanalysis against it, which is, for the most part, hasn't produced anything that's going to render it useless. that we know of. Over the next few years, we should be seeing more um, elliptic curve keys coming into play. Right now, they're a bit more of a novelty item. They're in limited use, but we should be seeing more of them in the asymmetric keys. And is the next guy here? Oh, okay. All right. Okay, I've got 2 minutes. What's that? Okay. What are elliptic curve keys? Elliptic curve keys is, and I'm a protocol guy, not a math guy, so I can't answer the. Basically, what it is it's a key. RSA is a key that's based on the difficulty of factoring a prime. DSA El Gamal, that's based on the difficulty of factoring a prime within some fields, something or other, but it's still going to produce comparably large keys for a given security. So if you have a 1024 RSA key, it's going to be in the same ballpark, about as strong as a 1024, RSA or El Gamal or DSA. They're all going to be about the same. What elliptic curve keys, the promise of elliptic curve keys, and over the next, history is going to tell us if it's correct, but what they're saying now is that with something like a 160 or 180-bit key, you can achieve the same strength as a 1024-bit key using a more, like an RSA or a DSA or an El Gamal type algorithm. Because of the mathematics involved, you can have a much smaller key that's going to be much more secure. So I think it was I forget if it was I think it was a 512-bit or a 1024-bit elliptic curve key would be comparable to like a 15K RSA, DSA, El Gamal type key. So what it allows, if the math bears out, is a much smaller key that gives a much more strength. So pass it over to our next speaker. He had 30 minutes to prepare.